will not go to the backend. So that is about the API management service, which act as the intermediator between the sender and the receiver, means client and the backend API. Now we will be talking about the learning path 9, that is develop event-based solution. So here we will talk about Azure Event Grid and Azure Event Hub. These are the two topics which we will be using it. Now, Event Grid and Event Hub are used in case of loosely coupled application where sender and receiver are not aware about each other. So in case of grid, we call it publisher and subscriber. We call it publisher subscriber model. Subscriber. And here we call it sender and receiver. Sender and receiver. Now, publisher and subscriber is based on the push-based mechanism. And it is based on polling. Means publisher will send the messages to the event grid and event grid will forward that to the subscribers. But in case of sender push the messages here and receiver will send a request, read request here, and then it will read the messages. It will send and it will read. So this is the idea behind it. Now let's talk about Azure Event Grid. So after completing this topic, you will get to know when to use Event Grid, how to use it, and how to use your event hubs. So event grid, when we talk about event grid, so event grid basically act as an intermediator which can handle the events that are generated on the source. And once the events are raised, it will forward to the event grid. Event grid will forward it to the handlers, right? So you need to understand what are the sources whose events can be handled by the event grid. So blob storage, resource group, subscriptions, event hub, media type, IoT hub, service bus, and so on. So let's say blob storage, in which when item is added, you want to do something. Item is deleted, item is updated. IoT hub, when device is created, device is deleted, device gets connected, telemetric data is received. So I want to handle those events. And handlers basically are the one which will react to the events, like Azure functions, logic app, event hubs, queues, maybe custom applications. Those applications or that code want to react to those events. So whenever item is added, then my function wants to know about that event and it wants to process that item. But they are not aware about each other. So whenever event occurs, it will go to the event grid topic, and then here the subscriptions are there, which will tell that for which event, which service is interested in. So it might be possible that for one event, multiple services are interested. So event grid basically has topics, right? So we can create event grid topic and where we can create subscription 1, subscription 2, subscription 3. So every subscription has a rule, right? And the action or the target, you can say that, right? So action. So action is which particular backend code you want to call. And rule is like when item added. If item is added, then only forward that message to the destination. That is subscription 1, let's say that. Now, this topic is related to IoT Hub. So when IoT Hub will raise that event, it will go to the topic. Topic will forward that message to all subscription, and whatever subscription is interested in that, then it will use that message and forward it to the destination. That is the event handler. That is the idea behind it. Now, there are a few terms that you need to understand. What is event source? And so event source is basically a resource which has the ability to raise the events. So I told you about the event sources. These are the event sources that I have. Then event is an action that is raised on the source. So event source will raise events. Event is an action that is raised and that information is going to be sent it to the destination. Then where this event information is sent. So event source will send this event information to the topic. Topic is like an entry point. Topic is like an entry point where the event's detail is forwarded. Now, topic says that I can forward that message which contain the event information to all my subscriptions. So I will broadcast that message. So I will broadcast that message to all the subscriptions that I have. And what is a subscription? Subscription basically is a part of your topic which has a rule which specify which message they are interested in. So whenever the message which they are interested in, which reaches to them, they have a target associated with that. And target is a handler, which want to react on that particular event. So that is the flow of it. Now, when we want to work with this, you need to understand what is the schema of the message that is sent from the event source to the topic. So every message that is sent from the event source to the topic has the ARN of the topic, subject, event type, event time, ID, and the data version and metadata. But the data part, what will be in the data, that depends upon the source. Blob source will have a different. IoT Hub will have different data, right? So data part will depend upon the event source. But these things are common. These parameters are common, right? Topic, subject, event type, event time, and so on. So these are the common things that they have, right? Now, whenever the messages are reached to the topic, so it will have all this information. So when it reaches to the subscription will check that what type of event it is. If they are interested in, then that will be used and forwarded to the destination. But I can also add filtration. Okay, event type is good, that you have item is added, but maybe I want to check if subject starts with that, then only forward that message. So extra level of filtering can be done. So we can apply another level of filtering. We can set other settings as well, like retry schedule, retry policies. Means if my subscription is trying to forward the message to the destination, and if the destination is not available, the message will be lost. But I don't want to lose the message. I want to retry it certain number of time. So I can define the retry schedule, which will retry the particular task as per the policy, right? Output batching. I don't want to send one message at a time to the event grid from the sender. I want to create a group of messages, right? Events when it reaches, I want to group those messages and send it to the destination for all together for performance. That's why we call it delay delivery. We can configure the delay delivery that as soon as message comes to the topic, by default, topic will forward to the subscription and subscription will forward to the handler instantly. But I will add delay delivery, like maybe 5 seconds. So as soon as event comes, wait for 5 seconds before forwarding it to the destination. I can also configure the dead letter events. Means after even retries, the event grid is not able to send the messages to the destination, so it will delete from the event grid. But I would like to save it in a dead letter queue, in a queue for specific time, so that I can see which event has failed to be delivered and why. So I can configure the dead lettering on that. Now we need to have permissions, right? The people who will going to create an event grid, the people who will going to create subscriptions, the people who are allowed to send the events to the event grid. And then event grid should have permission to send the messages to the subscribers. So we have different roles: event grid subscription reader, subscription contributor, event grid contributor, event grid data sender. So these are the roles that we must use, right? So when my application is trying to communicate with these resources, this event grid, so they must have the appropriate role to play with. Filtering event, I have just shown it, explain it to you that how the filtering works, right? It is not like on event based. You want to add an extra layer of filtering. So that can be configured. It can be subject filtering. It can be any filtering based on the information stored in the message. So before I move further, I would like to show you an example of it. So what I did is, let me show you a scenario, right? Then we can continue with that. So I have created an IoT hub. So this is my IoT hub. IoT hub has a devices section where I can add the device, I can delete the device, and device gets connected to the IoT hub and they can send the messages. Now, I want that when you add device or you delete device, I must call logic app. Now, logic app basically is what it is doing. It is sending a message to my teams that device is added and deleted, something like that. But this IoT hub doesn't know about logic app. Logic app doesn't know about IoT hub. So in the IoT Hub, there is an event section. When I click on the event, it will allow me to create the create a topic, event grid topic. So it will going to create a event grid topic. And within that topic, I can create subscriptions. I can create subscription 1, I can create subscription 2, and so. In subscription 1, I say that when device is added or deleted, target is the logic app, right? I can do that. That's what I did. So now, as soon as the device is added, it will forward the event to the event grid topic. Event grid topic will forward to all the subscriptions. This subscription is interested in that event, and it will forward that to the logic app. It might be possible that in this also, I say that when device is added, when device added, but add a filter, right? I can add a filter. In that filter, I can say that subject ends with JPG. Then only forward that. But device does not have a JPG, so it will not call that. It will only use this subscription. So that is the idea behind it. Now, if I'm working with the Azure resources, so they have their own topics, which are called system topic. They know that which type of events this resource can generate. So when I'm working with event grid topic, this is a IoT topic. It is of type IoT topic, which is system defined. It knows about what events this IoT can send. But it might be possible that I have custom application. I want that when user is added, then I want to call something. When user is deleted, users get registered, then I can create my own topic that is called custom topic, where I have to define my own events. So that when this application forward that forcibly, that event information to the topic, then it goes to the subscriptions, custom events are checked and then forwarded to the destination. So we have two types of topics, custom topic or system topics. So I'm going to give you an example of system topic. So I'll show you a logic app first, and then I will open the IoT Hub as well. So this is IoT Hub. So in this IoT Hub, I have a devices section. So where you can add devices, right? Or you can delete the devices, and these devices gets connected to it. So I have one device added. Now, if you click here, this is my logic app. If you go to the designer of this logic app, so it uses the connectors to connect to various services, right? Which I want to work with. It has lots of connectors, more than 400 connectors. So I say that it starts with when resource event occurs. When you click on it, I have configured it that this logic app will going to work if from this subscription, if from IoT hubs in that subscription, which IoT hub? The IoT hub name is my IoT hub demo, CW. If in that IoT hub event occurs of type device created and deleted, right? Then what you need to do? Then I would like to perform this. I added a connector of the Microsoft Teams. I say that I want to post a message as a user in a channel called IoT Grid Test. In a general section, the message is this cloud week. This is a cloud week demo and device is added or deleted. That's what I did. Now, let's see if I go to the overview of it. So I have tested it yesterday. So it shows me that it has already executed 3 times, right? But the date is yesterday. So now you can see what I'll do. I will, first of all, add a new device. So device 1, 2, new. I click save. So as soon as the device is added, this IoT hub will forward that message to the event grid, right? And event grid will call the logic app. So logic app will execute, but I'll show you the relationship, how I configured it. So it gets executed fourth time, right? You can see that. And I got a message here. So if I go to the Teams, and just a second, I will scroll down here. So I have a, yes, you can see today. That is basically a team called IoT Grid Test, where this is the Cloud Week demo, and it is today, right, at 12:41 p.m. So that is generated, one message. And then if I just delete a device, So it will going to again forward the message to the event grid topic, and event grid topic will going to call this logic app. So now it is executed one more time, and I'll get another message. So it is executed fifth time. So I'm expecting another message to be available here. You can see that. But how this has happened? So in my IoT Hub, there is an event section. In the event section, I have created a event subscription. So event subscription, which I have already added it here, is this name. It is endpoint is webhook, and it is calling that. Now, if you click on that to see what type of events I'm catering, so here it says that filter. I have added a filter to when item is created and deleted, right? Then I would like to call the destination, and destination is my logic app. I can add filters. I have not added any filter. I can add a subject filter. Means in your message you have a subject, so I can enable it. If subject begins with this or ends with this, then only forward that. It's not only event. If this condition is also met, then forward that. Or I can work with advanced filtering, right? Where I can check any other parameter in my message. I can compare its value. If it matches, then send it to the destination. And these are the deliverable properties, sorry, additional features. So I can configure my retry policy here, dead lettering, right? Expiration time of the subscription, batching. So all these things, what I discussed, can be configured here. Now, if I just go back, so if you want to create a new registration, you can click on event subscription here. If you want to create a new subscription, you can click create subscription, and then you can specify the settings here. The name of the subscription, what type of schema you want to use, which type of topic it is, what is the name of the topic, where the which device can which resource can send the messages to the topic, what events you are interested in, and then what is the destination. You want to call Azure function, you want to call a webhook like logic app, storage queues, what is your destination? So if you choose your webhook, then you have to provide the endpoint, the address of that URL, right, of that resource, HTTP based URL. So that's how I configured it. So that is basically an idea about your event grid, how event grid works. So event grid is basically creating an event grid topic which has subscriptions into it. Now we will be talking about the last part here, that is called Azure Event Hubs. Now, Event Hub is used when you have different devices, millions of devices or millions of applications which are sending the data in different formats, and you want to maintain that messages or information so that it can be processed, right? So it is an intermediator which has the ability to get the data from multiple resources in different format, and it can be used for forwarding that request to the receivers. Now, when I'm talking about Event Hub, it is Event Hub and Event Grid both. They are basically fully managed PaaS services which are based on the serverless architecture, because we are not defining the amount of space that we need. In both the cases, in Event Grid, it handles millions of the messages, millions of the events. So it adds more resources when more events come, right? And when the events are processed, it will release the resources. So you just have to pay for what resources you're consuming. Exactly in the Event Hub also, depending on how much messages are coming, how much data is coming, it will allocate the resources. And when they are processed, the, the resources are released, and you just have to pay for what you're consuming it. So it is a fully managed PaaS service. It is useful when you want to process your messages in real time. It is highly scalable, and it provides rich ecosystem because you can connect your Event Hub with your Kafka engine as well. Now, this is the architecture of the Event Hub. So Event Hub says that I can get the data from multiple sources, right? So your source one, source two, there can be multiple sources which can send the data to my Event Hub. So when I want to work with the Event Hub, I have to create an Event Hub namespace. I have to create a Event Hub namespace. When I'm creating an Event Hub namespace, within that, I can create multiple Event Hubs. So I can create Event Hub 1. I can create Event Hub 2 within that namespace. Each Event Hub, when I'm creating it, I will choose how many partitions I need. So I can create maximum 32 partitions. So I'm choosing, let's say, 2 partitions. So partition 1 and partition 2. So when these senders are sending the messages, so default behavior is that messages will be stored in a round robin fashion. Message 1, message 2, message 3, message 4. So it is stored like that. But yes, source has the ability to send the message to a specific partition as well. Right. So your messages are coming from different sources and send it to the Event Hub are stored internally in partitions. Now we have consumer 1 and consumer 2. Now consumer 1 wants to read the messages. So they cannot talk to the partitions directly. So every Event Hub has a consumer group. So there is a default consumer group where it maintains for partition 1, 0 messages has been read, 2, 0 messages. So consumer 1 send the messages request here, read request. So consumer group will give you this message and it will update that first messages has read from partition 1. When consumer 1 send a request again, it will give the message 2 and it will say that from partition 2 also one message is read. Now when the consumer 2 is sending the request for this from to the same consumer group, so he will get the third message, right? And it will update that second message has been processed. So it is good in case when multiple instances of the same application is running, so that you can process the messages much faster. Half messages will be processed by that, half messages will be processed by that, or more, right? But in some scenarios, second application says that no, I don't want subset. I want complete messages. It also wants complete messages. Why? Because it wants to process it differently, and this application want to process it differently, right? Maybe for logging. So in that case, I will create a new consumer group 2, where it will maintain a copy of that. Partition 1, 0 messages, partition 2, 0 messages. So it will maintain its own copy of the data so that same messages will be delivered to both of them. This will also get 4 messages. This will also get 4 messages so that we can process the messages differently. So that is the idea behind your event hubs. And when I'm talking about event hub, we can, because once the messages read, it will be deleted. But I want to keep these messages for a long time. So when we are creating an event hub, we can event hub namespace, we can choose the pricing tier, standard or the premium, right? Basic, standard, and premium. So in the premium one, I have the capability of capturing window. I have capturing option. So capturing option, when I enable it, so at an event hub level, so I can say that I can store the data into the blob storage or into the app, into the uh, data lake, data lake. So I can say that all the data can be sent to the blob or to the data lake. But when there are two options, timing window or the size window. I say after every 5 minutes or when 250 MB is generated. So whatever come first, maybe in 1 minute you have 250 MB in that event hub. So the data will be stored into the destination. Or maybe in 5 minutes you have only 200 MB. So after 5 minutes, 200 MB data will be stored. So it will capture it. Now the data will be there for longer time. I can use it for analysis in future. So that is the main crux of your event hub. Now, let me just open that event hub for you. Just let me go to the event hub that I created. So I have created an event hub namespace, as I told you. So event hub namespace is like a parent container where you have to create event hubs. So now this event hub namespace can have multiple event hubs. So event hubs, right? So I click on the event hubs and you will see that I have event hub, one event hub here. I can create another event hub. So when I'm creating a new event hub, I can specify the settings, like what name you want, how many partitions it will going to have, right? Cleanup policy, retention time, right? And so you click review and create. Even you can configure the capture time. If you capture it, if you enable the capturing capability, so I told you there are two windows, timing window and sizing window, and where you want to store it, storage or the data lake, so that you can configure it. Okay. Now, once it is configured, then you have your Sorry, my bad. So you have your Event Hub ready. Now you want to connect to that Event Hub so that you can send the messages. You can read the messages. So you need permissions. So what you can do is at an Event Hub namespace level, there is a shared access policy. When you go to the shared access policy, you can create policies. So one policy is already there at a namespace level. That is basically root access policy, right? So this policy will allow you to give a owner's right, will give you owner's right. So if you give this connection string to anyone, right? So that person can manage this Event Hub namespace. I mean, they can create an Event Hub, delete Event Hub, they can send message and listen to it. But it is a risk. So what I did, I created another policy. I give it a name sender and I choose send and I click create. So when I did that, so it has created it. Similarly, I can create reader and I say that read policy, listen policy. So when I do that, a read policy is created. You will see. Now you are a developer, you say I'm creating an application which can send the messages to the Event Hub. So I say, okay, so I'll click on that. I will give you this connection string. So using this connection string, you can only perform send operations. And another developer says that I'm creating an application and I want to read it. So I click on that and I will give you this permission, this connection string. So you can only read the data from that Event Hub. Now, if you're giving this connection strings from Event Hub namespace level, so this allows you to read or write the data in every Event Hub. But maybe one of the this Event Hub needs a different permissions. This Event Hub needs a different permissions, whatever I have created here. Just give me a minute. So you click on that Event Hub, and then this Event Hub also has its own shared access policies. So you can create this shared access policy at an Event Hub level. So if you create a policy here and you give this connection string, so only this Event Hub can be manipulated. So if you click add, so you can see that if you say send, means a person who will get a connection string will only allow you to send the messages to this Event Hub only, Event Hub 1. So you can control that. So that is the idea behind the whole topic, right? So I told you about partitions. I told you about consumer groups. I told you about receivers. I told you about capturing capability. Scale your processing applications. The key to scale for Event Hub is the idea of partition consumers. As I discussed with you, that it might be possible that I want to create multiple instances of my application so that I can process the messages much faster. So I can use the same consumer group. But if I want that each message should be processed differently by different applications, so I can create different consumer group, right? So consumer groups are used by the client application which want to read it. Sender does not need it, right? So if you want to create an application which can send and read the data, then you need to create two applications, sender application and receiver applications, and you will get the SDKs for the same. Now they are talking about that consumer group. So role and responsibility of consumer group is to maintain how many messages are received and processed. So every time consumer sends a read request, it will going to retrieve the message from the partition and it will add a checkpoint that this message has been received, right? So that same message cannot be processed again from the same consumer group. If you want to uh, process the message again, right? So you have to manipulate the checkpoint. You have to remove the checkpoint or you have to move your checkpoint to the previous state, which is little critical and it is not advisable. And by default, if your consumers are reading the data and if the request is going to the same partition, so ordering is guaranteed. So first of all, this, second this, and third this. But if your request goes to this and then this second partition, so ordering is not guaranteed between the partitions. That's why they say you should send the read request in parallel, in sequence, one after the another, so that you can get one message, process it, send second message, process it. So that is the idea behind it. Now, I told you about permissions, right? How to work with the permissions, sender, receiver, and owner. So you work with the shared access policies. Now, if you want to be a producer, if you want to create an application from where you want to send messages, so you will create an object of a class called Event Hub Producer Client, where you will provide the connection string of the sender or maybe the owner. And then you tell that which event hub you need to work with. Now, this producer knows that you have to communicate with that event hub using that connection string. Now you have a full permission. Now producer can say, hey, I want to get partitions, get partition ID. You'll get to know how many partition IDs you have. Then you want to send messages. So you can create a group of messages, or you can send a single message as well. So event data, if you create an object of event data, so this is a single message, you can send it. But if you want to send multiple message altogether, you can create an event data batch object by saying producer.create batch async. And then within that batch, you try to add multiple messages like event data first, event data two. So you are sending, you are preparing a, you can say a bucket of the messages. And then you ask your producer to send messages asynchronously on a child thread. So it will take all the messages as a single package and send it to that event hub. And if you have a permission, then those messages will be added. Now the consumer wants to read it. So when you want to work with a consumer, so you have to create an object of event hub consumer client. And consumer client should know that which consumer group you want to associate it with that, which connection string and what event hub. So it will say that I will try to connect with this event hub using that consumer group with this permissions. And once you have created that object, then that object has a method called read event async. So it will start reading the events that are, or messages basically. Event is messages that are there in the event hub. And then you can get the partition event and you can process the messages.